Welcome back to Pure Math School. Today we're going to look at we're going to introduce the fifth part of the introductory work, and this is what we're going to cover today. We have quadratics. If you have an expression in this form, x squared plus bx plus c equals to 0, for which a is not 0, we call that a quadratic equation. And we're going to look at basically three ways of solving them. That's by the factorization, by the method x equals to minus b plus or minus root of b squared minus 4ac over 2a, of which for this a, b, and c are the values in this equation, a, b, and c. And we're going to look at another method, that's completing squares. So let's start away with our first, that's, let me say, factorization, by looking at some of the examples in there. Say the first one is by factorization. So I think for example, this method is actually used. You first inspect your equation, the particular equation given to you. That's, you inspect this, inspect ax squared plus bx plus c equals to 0 if it can be readily factorized. If it can be readily factorized, and let's just start straight away. So if you first inspect the equation, if it can be factorized, then you can start handling question. I'll show you how you can inspect that easily by use of a calculator. Let us go to our first example. Let me say, put example, just say a solve x squared plus 2x minus 24 equals to 0. Remember, first we said we have to inspect that. Sorry, our solution. So here we're going to see we have x squared plus 2x minus 24 equals to 0. So for this case, we know our product is 24 with a negative, and we have our sum as 2. So we look for factors of 24 that if we multiply, we get negative 24. And if we subtract, when we add them, we are supposed to get 2. So 24, we have 1 times 12, that can give us that. We have 2 times 12, 1 times 24, that will give us 24. 2 times 12 can give us also 24. 3 times 4, times 8. Then we have 4 times 6. 7 cannot multiply any number to give you 24. 8, then we have 8 times 3, which goes back to here. That means perhaps all the factors are done. So now we choose which one. Let's see which one that can actually have a possibility of adding to give negative 2, or with the difference of negative 2. Difference of 2. 1 and 24, there's no way we can add to get that. 2 and 12, there's no way we can add 2 and 12 to get that. And the same to 3 and 8. So if you see 4 and 6, that means we can actually, because for us to get a positive 2, we can make 4 a negative. Negative 4 plus 6 can give us 2. And if we multiply this, we can get 24. So that's why we are considering that the factors we're going to consider for this case is going to be, now we say x squared plus, our 2 is now 6 minus 4. X, this representing 2, minus 24, giving us 0. So now we have x squared plus 6x minus 4x minus 24 equals to 0. So now that means we factorize out, we have here x common. If you remove x from this x squared, you remain with x. Then here from this remains 6 minus, we have 4 common here because minus 4, negative 4 is common, we remain with positive x here, then a positive 6 here, 0. So we have x plus 6 common, and so here we have x minus 4. If we remove this from this, we remain with this, remain with x. And if you remove this from this, we remain with a minus 4, so 0. So now we see that we have two numbers multiply themselves, and there's a possibility, and the result is 0. The only way we can see that this result is a 0 is when one of this is 0. When either this bracket is 0 or when this bracket is 0. That's when we can end up with these numbers, these expressions multiply themselves. to give you a 0. So that means we can either have x plus 6 equals to 0 for us, so that we have 0 times this to give us 0, or x minus 4 equals to 0, so that this time 0 would give us 0. That's the only possible way we can get this product to give us a 0. So we have here x, we solve for x here by multiplying, subtracting 6, so that we have only x remaining here equals to 0. If we subtract 6 here, mean negative 6, okay, or we add 4 here to remove this. We also add 4 on both sides, so that we have here remaining x equals to positive 4. So we have our x equals to negative 6 or x equals to positive 4. By use of a calculator, you can see how we can do that. We have our calculator there. So first make sure we clear it by pressing mod, then 3, put sign to clear that. Now we can see we have our equation. We go to mod until we reach equation, which is that. Then we select 1, we press 1 here. Now we go to unknowns. This unknowns is used for, this one is used for solving a simultaneous equation. We go to degree, then it's of degree 2, we choose 2. Now we enter our first value of a, because remember we are comparing that ABC. So ABC, where x, the coefficient of x squared is a which is 1. We press equal sign. Then the coefficient of x is the b, which is 2. Press equal sign. The coefficient of c, the value of c is negative 24. See here, c is a positive, but here is negative, so we consider negative is here. That negative, it's only one negative 24. So our first value is 4. The next value is negative 6. So press equal sign again. Yep. Now we can go to the next example. Next example, let me say example 2. Let me say B. We have 2x squared minus x minus 6 giving us 0. So remember that if you have the coefficient of x not 1, we need to multiply that 2 by this c term, so that we, this constant term, so that we get the real product. So for us to get that, we first multiply 2 and negative 6, so that we have negative 12 here. So now we look for factors of 12, that if you add up, we can get negative 1, and if you multiply, we get negative 12. Let's first split 12 before we get the factors. We have 12 times, 1 times 12 giving us 12. We have 2 times 6 giving us 12. We can have 3 times 4 giving us 12. 5 times 5 can't multiply in now to give you a 12. Then we have 6. Now 6 goes back there. That means our factors are done. So we choose now which one has a difference of 1 at least here. 1 and 12 no. 2 and 6 no. We have 3 and 4, which has only a difference of 1. So that if it for us to get negative 1, that means we can put a negative on 4, so that we have negative 4 plus 3 to give us negative 1. And now if we multiply negative 4 times 3, we can get a negative 12 here. If we multiply, we can get a negative 12. So now that means our x now is going to be minus 4x. We have, so since our negative 1 is that, now we're multiplying by x to give us that. So that we have here 2x squared minus 4x plus 3x minus 6 giving us 0. So then now we can factorize out. We have 2x squared and 4x. Which one is a common factor? We have 2x. I think you can see that. Times x to give us 2x squared. If you multiply this, we go back there. Minus here remain with only 2. Okay. Then plus, we have here 3 common. Here remains x if we remove this 3. Okay. Then minus 2 if we divide that 6 by 3. So now we're going to have here a common is x minus 2. So that we have here 2x remains if we remove this from this. So we have here 2x plus, if we remove this from this, we remain with 3, 0. So see the same case, we have only when this is 0, we multiply this to get a 0, or when this is 0, we multiply 0 by that to get a 0. That's the only possible way we can. So we say either x minus 2 equals to 0 or 2x plus 3 equals to 0. So when we add 2 here on both sides to remove that, remain with x equals to 0, or when we subtract negative 3 here, we subtract 3 from both sides, we'll have 2x equals to negative 3. So our x equals to 0, or you divide by 2, you remain x equals to negative 3 out of 2. So for that case, we are also done. Now I think we can now move to the next formula. 2 by the formula x equals to net minus b plus or minus root of b squared minus 4ac out of 2a. Which of those are the ones coming? This a, b, and c that you see unknowns there are coming from our original expression. Okay, so you get coefficients of x squared, coefficient of x, then the constant term c to replace in that equation. So for this case example, we have x squared plus 4x minus 1 equals to 0. So we compare with ax squared plus bx plus c equals to 0. So now we compare the coefficients. X squared, here we have coefficient of 1. So that means our a equals to 1, implies our a equals to 1. Then we see here our coefficient of x is b, their coefficient of x is 4. That means our b is actually 4. Here the constant is c, their constant is 91. So c is actually 91. So you can see that. Now we can now go and substitute these values in that formula. In this formula, x equals to minus b plus or minus root of b squared minus 4ac under the root out of 2 times a. This is a formula you need to just master. It's a formula that you need to just master. For now, we cannot comprehend that. Now we have here our a is 1, b 4, c 91. So we substitute that. Our b is 4, if you can see. So we have minus 4, which is the value of our plus or minus root of 4 squared minus 4 into our a, which is 1 here. Then our c is negative 1. You can see negative 1. All that under the root out of 2 times a, which is 1. Okay. Now you proceed to now simplify that, because we have now substituted. Now we have here minus 4 plus or minus 4 squared is 16. So we have here 16, which is 4 squared, minus now 4 times 1 times negative 1. 4 times 1 times negative 1 is actually negative 4 minus 94, which becomes a plus to give us 16 plus 4, which is a 20. So we have here the whole of that root is 20, all the thing under there, out of 2 times 1 is 2. So now we have a positive of when x is when we have a plus here and when it's negative. So we have two cases. That's either x equals to minus 4 plus root 20 out of 2, or x equals to minus 4 minus root 20 out of 2. We have considered this plus and this negative separately now. That's how we can now have that. So now we can maybe use a calculator, because I see this is not going to be an exact number. We can let me first clear my calculator. So now we have here minus 4, okay, negative 4 plus root 20. We have that divided by 2. What do we have? 0.236. Let's round up to 2 decimal places, so that we have our x equals to 0.26. Now it will come to 24 to 2 decimal places. Okay, or x equals to, we have here minus 4 minus root 20, giving us that. Then we divide by 2. You can see we have negative 4.236. We round up to 2 decimal places, so 4.24 to 2 decimal places. Also, we need to specify that to show that you eliminated some, you left out some numbers, or you just rounded off to get that, because the number wasn't exact. It was a decimal, I think, here, even without recurring. So now let's go to the third method, by completing squares. So we have in this method, our basic thing here is comparing. We're going to use the expansion we looked at under our remember the three quadratic identities, and for this case we are specifically going to use x plus b squared being given by x squared plus 2bx plus b squared. If you remember, under the three quadratic identities, we had this, and we had that. So for this case, these two can help us here. When there's a plus and when there's a minus, you consider this, where this one was given by 2a minus 2ab plus b squared, and here the only difference was that here there was a plus. You check our previous video if you want to check that, in case you're not familiar with it, and here was given by that. So for this case, this 2 is going to help us for this case of completing squares. So now that means now in this we observe that the square of this b squared is actually the square of the half of the coefficient of x. So that means if you're given an expression, a quadratic expression, we need to make sure we can generate half the coefficient of b of x, half the coefficient of x, and we square it, so that we have another separate expression within that expression that can make us come out with 1. Let's just check out with an example. Let me say we have solve x squared plus 3x minus 1 giving us 0. So that here we have that. Now we need to compare with that. Let us try to create half of this squared, so that we can now just write in this form to simplify our work. So let us say we have x squared plus 3x minus 1 equals to 0. Now let's create that. We have x squared plus 3x. We can take 1 the other side. Okay, let's first leave it here. Maybe we can add half of this. That is half of 3 is 3 out of 2. Then we square it. Then we remove it away, so that it appears like we have not caused any change to that quadratic equation. So we have added the half the coefficient of this and squared it. Then we even removed it, so that is like this could cancel to go back to 0, and we'd have the same equation we had before. Now let's take away this one the other side, so that we remain with this, so that we can express in that form. As you can see, half of a coefficient of b of x is squared. Here half of the coefficient of x is also squared. That means we can say here, we could say x plus that b, the plus b, which is half of x, then is squared. So that means you can also have x plus half of the coefficient of x, then is squared. That's a simple way we play with this completing of squares. And so we have x squared plus 3x plus 3 out of 2 squared. I said we take negative 1 the other side. We have 1, then plus 3 out of 2 squared. From this here, from this we took this the other side, we added 3 out of 2 squared here, then we added 1 here, and we did the same the other side, so that we can have that the positive the other side. That's what we simply did. So now we have that. So now since we say this is half of this, we can just say x plus half of the coefficient of that, then square that, giving us 1 plus this, now square of 3, then square of 2, that's 9 out of 4. So 1 plus 9 out of 4, we'll have here SCM 4, lowest common factor 4, then so we have here 4 plus 9 to give us 13 out of 4. 13 out of 4, now we get the root on both sides, x plus 3 out of 2 give us, now under solving quadratic equation, to reach the point of you're getting square of a number, especially for this, you need to consider both plus and minus of the result. Why? Because if you square negative of root of 13 out of 4, you go back to 13 over 4, and the same as if you square positive of the root of 13 out of 4, you still go back to 13 out of 4. That's why we put there two answers, both positive and minus. So we have here x equals to plus or minus now root of 13 out of 2, because now root of 4 is 2. That property we looked previously, you understood, so that can help us realize how this comes about from there. So that we can have here minus 3 out of 2. So we have two cases, plus and minus. So either x equals to plus positive root 13 out of 2 minus 3 out of 2, or x equals to negative root 13 out of 2 minus 3 out of 2. These are the two cases we have. So those are the two values of x. And if you check your calculator properly and you enter that figure in the calculator, you're going to get 0.30 to 2 decimal places, and x will be for this side it's going to be negative 3.30 to 2 decimal places as well, because that result wasn't exact. And now we're going to look at another thing under this completing of two squares. Completing of squares. We're going to make some note here. Completing of squares is also used to help us get the minimum and maximum value of an expression. Let me just say completing of squares is used to find maximum and minimum value of a quadratic expression. So you look at an example how we can come about that. So example to make us confirm that notice that we have just put. Now we have, let's consider let's find the minimum value. Let me say find minimum value of x squared plus 3x plus 4. So we have our x squared plus 3x plus 4 being given by, so we are going to create the same thing. We are still going to use this that we looked at before. X squared plus 2bx plus b squared. It's the same thing we're going to use. So now we're going to create half of the coefficient of this squared, x squared plus 3x, then plus 3 out of 2, half of 3 out of 2 squared. Let's remove it so that it causes nothing to our equation. Then now we add plus 4. So these ones can cancel out to go back to that, but we have introduced it for a purpose. So now we're going to have here, we have x squared plus 3x plus 4 given by x squared plus 3x plus 3 out of 2 squared, of which we removed it so that we don't cause any change to our equation. Now we're going to try to see how we can manipulate that and help us reach our minimum value. So we realize that here from x plus b squared equals to x squared plus 2bx plus b squared. This squared is a half of the coefficient of x. So we already have something like that. We have x squared plus 3x plus 3 out of 2 squared. That means this is half the coefficient of that. So that means we can simply write x plus half of the coefficient of this, then we square like that. So that here we have plus 4 minus 9 out of 4. Okay, so here that means we can simply write this as x plus 3 out of 2 squared, since this half the coefficient of x. As you see, half the coefficient of x squared squared gives, this will just written as x plus the half of that and squared to give us all of that expression. That's the same case that applies here. So now now we have 4 minus 9 out of 4. Let's see how that comes. We have a LCM of 4, so we have it there 16 minus 9. We have 7 out of 4. Okay, I know everyone is familiar with this as far as this level is concerned. And so we have here now therefore x squared plus 3x plus 4 is given by that. So now how do we now know the minimum point or the maximum point of this expression? Realize that we have x plus 3 out of 2, the whole of that is squared. That means there's no chance that this value is a negative value, the whole of this. The value of this expression can ever be negative for any value of x. Why? Because it's squared. If you square a negative number, you get a positive number. If you square a positive number, you get a negative. You still get a positive number. So that implies that x plus 3 out of 2 squared is always greater or equal to 0. Remember your inequality now for second video, I think second video, that is always greater or equal to 0. So that means that means the value of this will actually start when the whole of this is 0 and it continues. That means you add that plus, so that means actually our beginning value in this is when this is 0, because it starts from the smallest, which is 0. If this starts from 0 then onwards to positive values, that means if you substitute value of x, that makes you have either 0 or values greater than 0. We can have a minimum value starting from 7 out of 4. That's when this is 0, and that's when x is negative 3 out of 2, which cancels that expression inside the bracket, so that we have 0 squared, which results to 0 plus that. So actually we have x squared plus 3x plus 4 is minimum when x equals to negative 3 out of 2, and the minimum value is 7 out of 4. That's it. The maximum value for that case is endless, because the values of x is going to always increase. Consider x to be a real number. Now we check on another number, one more number under that. Let's say the example, we can say find, now this time let's consider maximum value of 5 minus 2x minus 4x squared. Okay, for x being under inequalities, we saw what this means x should be a real number. And it's a real number, that makes our number line complete if you connect the previous videos. So now we have that 5 minus 2x minus 4x squared. Let's rearrange that. So I have minus 4x squared minus 2x plus 5. Okay, now let's see. For this case, remember, we need to be careful. Our x squared term has a coefficient of which is not 1, so it's a negative 4. So we need to first create that 1 there. So if you factorize out 4 from here, if you factorize here, we'll be saying negative 4. We want to create coefficient of 1. Let's consider maybe here only. Okay, let's consider this first set here, first expression here, so that we have x squared here. So if you divide this by negative 2 out of negative 4, we remember that I think half, and which is positive since we have pulled out negative, so we have positive half x plus 5. So that if you open bracket, you go back to minus 4x squared, then half times negative 4, that will go to negative 2. So we go back to negative 2x. You have to be careful there, you can easily make a mistake there. So we go ahead. Now we have minus 4 into x squared plus half x plus 5. So we have minus 4 into x squared plus half x, then plus 5 outside. Now we create half of that. Let's try to create this x squared plus 2bx plus b squared. Okay, so that we create this so that we can write in this form. So we have equals to minus 4 into x squared plus half x. Now half of half is actually half of half is 1 out of 4. So that plus 1 out of 4 we square, then remove that 1 out of 4 again, so that because no change inside there, plus 5. Okay, you get that? So that we have here minus 4 into, now you see this first expression, this coefficient of x is actually is half is squared here, which is that coefficient. And you observe this first expression, you have half of the coefficient of x squared, just like there, half of the coefficient of x is squared here. That means if you have something like that, x squared plus coefficient of x plus a half of coefficient of x squared, you can simply write in that as x plus half of that coefficient of x and just square the whole term. So for this case, we're going to have x plus half of the coefficient of x, which is 1 out of 4. Then we just square it. Then we have here now minus our 1 out of 16 plus 5. So that here we have now 94 into x plus 1 out of 4 squared, then plus 1 out of 4. If you open this bracket, negative 1 out of 16 times 4 becomes positive 1 out of 4, then plus 5. I've just opened the bracket. Now I have 94 into x plus 1 out of 4 squared. There we have 1 out of 4 plus 5 out of 1. That means the same is 4. There we have 1 plus 20, which is 21 out of 4. So there we have plus 21 out of 4. In other words, we have now our expression. So the expression we had, that's 5 minus 2x minus 4x squared equals to 21 out of 4 minus 4 into x plus 1 out of 4 squared. Now they wanted to find the maximum value of this expression, 5 minus 2x minus 4x squared. That means now we have to see that here we need to check now the values of x for this case and see what's actually how the pattern of that expression, how it's going this. And we also observe that here we have x plus 1 out of 4, since it's squared, is always greater or equal to 0. Okay, so that means this expression can ask values that start from 0 up to positive numbers. So now if you, and it's that minimum value of this expression is when x is 91 out of 4. That's when we have here 0 squared, so that we have actually the first value being 21 out of 4. So let's see if we go forward. We tried 91 out of 4. Now let's try a bigger number. That's now 1. Let's say x is equal to 0. That means we have 1 out of 4 squared. That's 1 out of 16. Let's say 4. Let's say 4 times 1, that fraction thing, out of 16. We're going to have 1 out of 4 coming there. So 21 out of 4. 21 out of 4 minus the answer. Okay, we're going to have 5. So we have 5. We have seen that going to 5. If we say, let me say 1, we're going to have 1 plus 1 out of, let me say 3 out of 4. 3 out of 4 is 1.5. 3 out of 4 is actually 1 and 1, which is bigger than 1. Yeah, bigger than 0. We try that one also. We have 1 plus 1 out of 4. That's, 3 out of 4 plus 1 out of 4. That's actually 1. That being 1. 1 squared is 1 minus 4. So we have 21, 21 out of 4 minus 4. That's when x is 3 out of 4. Let's make it a fraction. That's 5 out of 4, which is 1.25. If you see that, it's 1.25, which is, the other one was 5. Now bigger value. See that now bigger values are decreasing. The first one was when x was 0. So bigger values of x, the whole of this expression was 5, but now the whole of this expression is 1.25. I think bigger value of x is reducing. Let's now start below, try below 0, which is, let me say 91. X 91 plus 1 out of 4. We are going to have 93 out of 4. Now 21 minus 21 out of 4 minus the answer. We're going to have 6. Now you see, at 0 it was 5. So when as x values decrease, we're going to have bigger values of this. But as x values increase, we're going to have what? We're going to have actually smaller values. So for this case, when do we have the whole of this expression bigger? It's actually when biggest. That means when this expression should be actually greater or actually greater or equal to, this one should be greater or equal to 0. And now we're going to see that it's going to start when we have here x being actually x being negative 1 out of 4. That's when it's 0, because at 0 is this at maximum. But now as we try to increase the value of x, we're actually going to have values that are actually decreasing instead. So that means for as values of x increase, since this is actually bigger and we try to insert values of x that increase, we are going to have smaller values. So actually the maximum value will be when x is negative 1 out of actually negative 1 out of 4, and that's when we are going to have our maximum value, because if values of x increase, we're going to have a decreasing value of 5 minus x squared. So we have maximum value of 5 minus 2x minus 4x squared is 21 out of 4 when x equals to negative 1 out of 4. That's when our value is maximum. So for today that's all. Please, may you we hope that I hope to see you in our next video. Thank you. Like, subscribe and share, and also comment if you have anything you want to say about the video. And let's see you in our next video.